Hey Algebra 2 Lab, so in this video I'm going to be going over section 3.5, which is graphing a polynomial in factored form. In our last video, or our last live class actually, we went over the steps. So what you're going to want to do is first solve for your x-intercepts, and then you need to determine how each x-intercept intersects the graph. And this is important, so just to go over it, it can go straight through. And that happens if we have a single exponent. So if the exponent is 1. If the exponent is even, so if it's squared to the 4th to the 6th, any even part, it's going to bounce off, just like a quadratic. And if it's odd, not 1, odd, any other odd number, it's going to flatten out like a cubic. So then we determine the end behavior, and then we can graph it. So today we're going to apply this and go over those steps. We'll do a couple of examples. So the first example, so we're going to graph f of x equals x plus 3 squared times x minus 1 cubed times 2x. So first thing you want to do, like we have in our directions from the other day, is to set it equal to 0. So we can solve using the zero product property. This is just like a quadratic. So once the whole thing equals 0, now we can use the zero product property. We're going to set each factor equal to 0. We're going to ignore the exponents because this is x plus 3 squared, so it's the same as x plus 3 times x plus 3, so it would just be redundant. And we solve for each intercept. So I'm going to subtract 3, add 1, and divide by 2, so I get 0. So these are the 3 zeros or roots. I could write them as coordinate points if I want for x-intercepts. So the next thing we want to do is determine how is it going to intersect the graph. So remember, this is where you look at the exponent. So because the exponent of the factor for negative 3 is 2, and 2 is even, remember think of a quadratic, this is going to intersect by bouncing off. For 1, the factor or the exponent was cubed, which is odd, so this is going to flatten out. And then here the exponent is 1, so this is going to go straight through the graph. So now we have each 0 and how it intersects. Before we graph, we need to figure out the end behavior. So for the end behavior, we want to do the leading term test, which means we need to identify what is the degree. I'll do it over here. What is the leading coefficient? And then we can use that to figure out the end behavior. Now, in order to figure out the degree and the leading coefficient, we need to look at our equation. But the problem is it's not in standard form. Now, you don't have to put it in standard form, but you have to kind of think about what would the leading term be. So there's a little, you could do this in your head or you could show your work. So I'm going to show you kind of the thought process. So when we look at the equation, right, If I were to expand this, I'm going to use my whiteboard so that I can kind of show you what I mean. If I were to do x plus 3 squared, right, that would be x plus 3 times x plus 3. And the first thing I would do is multiply these, so I get x squared and then a bunch of other stuff. So we can kind of think about this, because all we care about is the first term, as going to be, this will end up being x squared. And then we have to think, okay, well, what about this one? Right, because technically we would have the x minus 1 cubed next, and we would bring it down. So we just focus on the x minus 1 cubed. You don't have to write this part down. It'd be x minus 1 times x minus 1 times x minus 1. Oops. And this would give us x squared and then other stuff. And then we multiply this, we'd get x cubed and then a bunch of other stuff. So this will end up giving us an x cubed. And this is just 2x. So then we can literally just multiply these together, and that's going to give us the leading term. So x to the x squared times x cubed times 2x. So that would be 2x, and then we can add the exponents. So 3, 4, 5, 6. So the leading term if we were to expand this whole thing, would be 2x to the 6. So that means our degree is 6. Our leading coefficient is 2. So because this is even and positive, our end behavior will be up, up, right? Even, same direction, positive, we end going up. So now I'm going to put all of this together, and I am going to graph. So remember, your y-axis doesn't matter because we don't have enough information to know the height of the y values, but the x values matter. I'm going to make my scale be half. Alright. So I'm going to first plot my intercepts, so -3, positive 1, and 0. Then I'm going to start in the appropriate area for end behavior, so top left. And I'm going to come down, and then I need to go, okay, how am I supposed to intersect here? Because this has an even exponent, it's going to bounce off. So I'm going to come down and bounce off. And then in between here and here, I need to turn. And how am I going to intersect at 0? I'm going to go straight through. And then I need to turn again. And here we're going to flatten out. Probably could have done a better job with the flattening out. It's kind of hard to graph. A little better. And that's it. So it's kind of a lot. So maybe let's do one more quick video. Or not quick video, sorry, quick example. Alright. So for our next example, let's do g of x equals -2 times x minus 4 squared times x plus 5 cubed times 2x minus 3. So first step, solve for those zeros by setting it equal to 0. Set each factor equal to 0, and we can ignore the 2 because there's no x. I mean, if you want, you could not ignore it and be like, well, that doesn't make sense. So x will equal 4, negative 5, and positive 3 halves. How does it intersect the graph? So because this is even, it's going to bounce off. This is odd, so it flattens out. And this is 1, so it goes straight through. So now I need to do the leading term test. So if you want to figure out the leading term, right, you can think, okay, so this will end up being x squared, this will be x cubed, and this is just 2x. You do have to take this negative 2 into account, and then multiply them all together. So it'd be negative 2 times 2, so it'd be negative 4, and then x to the 6th again. So then the degree is 6. The leading coefficient is negative 4. So because that's even and negative, that means my end behavior will be down, down. And now I just need a graph. So again, y-axis does not matter. Alright, I'm going to go to negative 6. This time I did a scale of 1. And positive 5. Okay, so first thing, plot where we're going to intercept the graph. So positive 4, negative 5, and 3 halves, which is 1.5. Start with the correct end behavior, so bottom left, and then how are you going to intersect? So here, at negative 5, it flattens out. Don't forget your arrow. We have to start to turn back. So we need to go through at 1.5, and we're going to go straight through. And then we need to turn back, and we're going to bounce off at positive 4. And that's it. So practice will make perfect, so take each step slowly, step by step, and you will get it.